Let's begin. Today's June 15th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards and its 6 verification cards. Let's go to turingmachine.info for the details. So in today's puzzle, we are using the following 6 criteria cards. Criteria card 3, 5, 9, 14, 16, and 21, and we're using the orange verification cards. The code above is what you use to go to turingmachine.info to search for today's puzzle and get more details. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, criteria card C, and on the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at the middle digit, the square digit, and compares that to the number 3. So should the value of the square digit be less than 3? Should it be equal to 3? Or should it be greater than 3? Criteria card B looks at that first digit, the triangle digit, and will let us know whether the value should be an even digit or an odd digit. Criteria card C looks at our 3-digit code solution and will let us know how many of those should be 3. Should there be no 3s? Should there be a single 3? Perhaps 2? Or maybe even all 3 are 3s. Criteria card D looks at the 3 digits, triangle, square, circle, and will let us know which one's the absolute smallest. So should the triangle be the smallest? Should the square be the smallest? Or perhaps the circle should be the smallest. Criteria card E again looks at our 3 digits in our solution and will let us know comparing how many evens to odds. So should there be more even than odds, or should there be less even than odds? And finally, criteria card F again looks at our 3 digits in our code and will let us know if there is a pair among the 3 digits, meaning there's a repeating digit, as in the example 131, or alternatively, there is no pair, but there are 2 different possibilities. It could be that all the digits are unique, none repeat, or basically you have a single digit that repeats 3 times, as in the example 222. And remember, our objective today is to find this unique 3-digit code that abides by the 6 criteria cards that we just discussed. And we're going to start off with our initial proposal of 314. So the first thing I want to do is I want to find out if that first digit, that triangle digit, is an even or an odd. So I'm going to test criteria card B. Okay, so the Turing Machine approves. So if I go back to my proposal, notice that I did choose an odd 3 as my first digit. Since the Turing Machine approves, that means it's telling me that yes, the triangle digit is an odd digit. Now it doesn't mean that it is absolutely a 3, but it is odd. So triangle is an odd digit. And so above here, I'm going to cross out all of the evens. So it can't be a 2, and it can't be a 4. Okay? And we do have this criteria card E that will let us know how many even to odds there are. So let's go ahead and test criteria card E. Okay, so it does not approve of my proposal. Notice that in my proposal 314, I've got 2 odds to a single even. It does not agree with that. So in fact, what it's telling me is that there should be more even than odds. So that's what I'm going to write down in my notes for criteria card E. That even should be greater than odd. Okay, and well, as it happens, we know triangle is odd, and if there are more even than odds, that means that we can say that square and circle are both even. So square and circle are both even. Okay, well, since we know that they're even, well, we can cross out all of the odds. So it can't be a 1, can't be a 3, or a 5, and that's true for both. So now we know, at least kind of structurally, that our solution is going to be odd, even, even. Okay, now we do have this criteria card F that will let us know if there's a pair. And if there is a pair, then we know that it's going to be the same even digit for both square and circle. If not, then it would they would switch, so to speak. So let's go ahead and test criteria card F. Okay, so it does not approve of, again, my proposal of 314. Well, I do have all unique digits, so that means that no pair is incorrect. So yes, there indeed needs to be a pair of digits. So that means that criteria card F, in the notes, I'll just say that there is a pair. Okay, so again, so that means that it's going to be either 2-2 or 4-4. Well, that's very interesting going into round 2. So we've already finished our 3 Turing tests for round 1. So now we're going to the phase where we're going to discuss what could be a good second round proposal to get us closer to our solution. Okay, so we did test A, which is telling us a little bit about the square digit. Well, this is basically going to be a 50-50. So this, in fact, will let us know what square and circle are going to be, since we do have a pair. So that's going to be great. We'll get 2 numbers in one test. And so then it becomes, what would triangle be? Well, we also have this absolute smallest. Oh, that's interesting. Okay, yes. So we have this absolute smallest, and we have whether there's a 3 or not. So let's think about this. What if if 2 was the smallest? You could, in fact, be able to figure out whether it's a 3 or a 5, since anything that's greater than 2, well, that's 3 or 5, and criteria card C will let us know yes or no. Remember, since we do have only one odd digit, it's either going to be a 3 or not. So let's see what else. So yes, criteria card A will let us know what square and circle is going to be. And then we also have this smallest. So that's very interesting. Oh, well, of course, I just didn't think about it. So obviously triangle has to be the smallest, right? Since we do have a pair, obviously triangle has to be the smallest. So I think without testing it, we can deduce that that has to be the case. Okay, so let me actually write that down in criteria card D, right? Whenever you have a pair, well, it's the non-pair that can be the absolute smallest. So we'll say that triangle, and of course I'm saying that we're deducing, so deduce that triangle is the smallest. Okay, so I think that's going to be one less thing to test. So now the question is, can it be a 1? Well, I think, let's see, can we say, well, if indeed, well, if triangle is the smallest, I guess, I mean, obviously it could be a 1. So let's see. Well, okay, so if triangle is the absolute smallest, then obviously it can't be 5. Okay, so that's another uh, uh, positive thing going towards finding our final solution. So let's see if it is a 3 and it's the smallest, then we know it'd be 344. If it was a 3, if it's a 1, so I think that's the answer. I think it's going to be 344, because if it was a 1 and it's the smallest, well, obviously that means that there is no 3. But how would you be able to distinguish? Let's see. Oh, perhaps that's what's going to happen, is that it is going to be a 1, and then a square will determine which pair it's going to be. I think that's how it's going to play out, because remember, all these 6 cards are essential. There's no redundant information. So if in fact if there were a 3, that would mean that this card would be irrelevant, because if we deduce correctly that 3 is the smallest, then the answer is 4. So that means that, I believe, again, so let me write this down in criteria card C, that I'm going to deduce there is no 3-digit. And because, again, if there is a 3-digit and it's the smallest, then of course it's 4. Does that make sense? Right, and then of course this would be redundant, because we know it's 4. So I'm going to say that the actual answer, excuse me, is going to be 1, and then whatever square criteria A tells us. So I'm going to write up, I'm going to say 1, what could it be? I'm going to say 144. Okay, so based on just testing criteria card A, that should be good enough. Okay, so let's go ahead and test 144, and I'm saying that the only thing I need to test is criteria card A. Okay, so that is correct. So let me actually write this down. Again, criteria card A has to do with the square, and what it's telling me is that square does need to be greater than 3. So let me go ahead and write that down, and that is in section A. Oops, I apologize. This should have been in B. So instead of deleting it all, I'll just write this down. Square should be greater than 3, which means that it's 4, right? So that means we should be able to cross out the 2's. Okay, and again, I am deducing that there is no 3 because of that redundancy. So I feel confident that it should be 144. Let's go verify. So let me just type it up here. So 144, let's go test. One, 4, 4. Fantastic. And because we tested less than the number of criteria cards, I feel very confident that we beat the Turing machine. Okay, so we tested B, E, F, and then A. So let's go type that up. So B, E, F, and then A. And let's see how we did. Wow, very cool. So we did it in 4 questions, and the Turing Machine did it in 7. But of course, we had these just amazing aha moments where we were able to deduce, again, based on how to play the Turing Machine game. And yeah, these 2 deductions that really, allowed us to not have to test both C and D, right? They were kind of missing in there. Well, this was, I think, a fantastic solve. If you do have any comments, please do share them. If you like the video, please give it a thumbs up so that more people can find this channel. And if you don't want to miss out on any future videos, please subscribe to be notified. Well, until next time, have a great one.